model development and its limitations. First of all, we can see the model development. As we know, the definition of the or meaning of a model is the simplified representation of the system or the crop model, which will be represent the crop, that is to solve the complexity observed in the system. And then modeling as the method or the analysis and then detect these errors or the complexities observed in the system in with the help of the mathematics or the statistical and the computer system, which will be minimize or reduces these complexities in the real world time as the concept of modeling. And then simulation, which will be the integrate with these mathematical equations, that is the differential equations or partial differential equations, as well as the statistics and these different digital computers, which will be integrated and to reduce the complexities observed in the system. These are the different detailed meaning of this modeling and the simulation, and then as well as the crop simulation. Today we discuss about the how to develop the model. As there are different steps, that is three major steps to develop the model. That is first one, strength. The strengths of the model in general includes the abilities, that is to provide framework of the understanding of the system and investigating how the manipulating its effects in its various components. As we see here, the framework to develop the or build up the framework to regarding the to understand this system or to reduce the complexity of the system, and accordingly the investigating the how the manipulation or the compilation of the system with the help of the various components. This is a major point, that is strength. And in this strength, there is also uh, important ability, that is evaluate the long term impact of the particular interventions. Whatever the long term impacts, especially in the system, which will be intervened or used to evaluate with the help of this strength. Then also provide an analysis of the risk involved in adopting the particular strategy, and then also the provide the answer quicker and more cheaply than it is possible with traditional experiment. As we can see here, the strength is the important step is for the model development, which includes the different abilities, that is provide the analysis of the risk ability, then also provide quicker and more results or cheaply results will be observed in the for development of this model, and also provide the framework for better understanding. These are the major highlights of the strengths which will be necessary for the development model. Next one step, that is the model calibration. As in calibration is the adjustment of the system parameters so that the simulation results reach in predetermined level, usually that of an observation. As you can see here, in case of the calibration, the system is where the different parameters can be adjusted so that the simulation means mathematics, statistical or computer, which will be get better results with the help of this integrated system. Next one, the third, that is model validation. The model validation stage involves the confirmation that calibrated model closely represent the real situation. As we see the last point, previous point, that is number 2, model calibration, where the adjustment of different system parameters which will be needed for the proper calibration of this model. And in case of the validation, the model validation stage is the confirmation stage, which will be calibrated model closely represent with the real situation. Then also procedure consists of the comparison of the simulated outputs and the observed data that have not been previously used in the calibration stage. And ideally all the mechanistic models will be validated both level of the overall systems output and the level of the internal component and processes. As you can see here, the model validation, where the model calibration stage which will be involved for the confirmation. Also they consist of different simulated outputs and the observed data which will be used for the calibration stage. And then ideally all mechanistic, these are the type of model which will be different mechanisms which involved in the model, which will be validated both with the level of overall systems and the level of internal components and the process. These are the different steps which will be involved in the model development. Next one, we can see the model uses or the uses of model. That is, as a research tool, the uses of model are various types. That is, first one, research understanding. For the as a research tool, the major use of the model, that is in the research understanding. Most of the development in the model that ensure the integration of the research understanding acquired through the discrete disciplinary research, and also the allows the identification of the major factors that drive the system and can highlight areas where the knowledge is insufficient. In case of with the help of this model, research understanding is mainly concerned with this integration of this research understanding through the discrete disciplinary research, and also identifying their facts. With the help of this model, we have to identify the research queries, the research highlights, or the research lacunas which will be going to develop for the improvement of the research activities with the help of this model. Next one, the integration of knowledge across the discipline. Adoption of the modular approach in the model coding allows the scientist to pursue his discipline-oriented research in the independent matter, and at later stage to integrate the acquired knowledge into the model. As with the help of this model, which will be integrate the different kinds of knowledge across all the types of disciplines, which really helps to the to integrate or to develop this research activity, or the mainly out of the different modular approaches. Also, the scientist has to be adopted different types of discipline approaches to improve the research activities regarding the integration of the different kinds of knowledge. Then third one, that is improvement in experiment documentation and data organization. With the help of this model, the especially simulation model development, the testing and application demand of the use of large amount of the technical and observation data supplied in given units and in particular order. As the research documentation is very important for part in the research and development, where the data is also to be organized on the basis of the research documentation. If the research documentation is, if it is in its complexity is found, then there is no value of the research activity. Then with the help of these models, the special simulation model, the research will be developed in a proper way with acquiring the and integrating the knowledge, different kinds of knowledge from the various disciplines, and the also the understanding of the research. Next one, we can see the genetic improvement, especially in the different crops which have the genetical characters to be studied with the help of this model, and also their improvement, especially gene interaction with the different kinds of the environments, or gene to interaction, which will be helped for the usually adaptation of or properly adaptation of these crop plants. We will get the potential yields, or the genetic behavior of the plants will be studied with the help of these models. Especially simulation model become more detailed and mechanistic, which can be mimic or reduce the system more closely. Also, the more precise information can be obtained regarding the impact of these genetic traits. Different kinds of traits are the obtained observed, especially on the economic yield, and these can be integrated with the genetic improvement program. Then next one, the yield analysis. When the model is a sound physiological background is adopted, it is possible to extrapolate to others environment. That is to use several simulation models to assess the climatic determined yield in various crops. Next use of this model, that is as a crop system management tool. In that, the first one, cultural and input management, has the management decision regarding cultural practices and the input have the major impact on yield. As we know, the management of input is not properly or improper, there will be the effect on the yield potential or the target yield of the specific crops. Their impact on the major yield. Simulation model that have the specifications of the management options offer relatively inexpensive means of the evaluating a large number of strategies that allow the rapid become too expensive if the traditional experiment approach were to be adopted. If the traditional variety or the traditional research approach use continuously, then there will be affect the yield potential of the particular crop, and hence they need to improve the cultural practices according to the suggestions of the models or the according to simulation models will be improve the input supply or the inputs management as well as culture practices, and accordingly enhance the yield of crop. Then next one, risk assessment and investment support. As you know, the using of this combination of the simulation models will get the increase the yield and gross margins or the net returns, and as well as economic risk and weather related variabilities can be assessed with the help of this model. Then also the site specific farming, as the profit maximization may be achieved by the managing farms as set of subunits and providing the required inputs at the optimum level to match the variations in the soil properties across the farm. As we know, the site specific farming is the where the sites or the place which will be apply the inputs properly. If it is the lack of the use of these inputs in proper way, that will be uh, uh, impact on the profit margins or profit maximizations, as hence there is need to uh, divide the farms or the plots into subunits will be helpful for the managing, and they also provide input in the optimal level to get the target yield. Then as a policy management analysis tool, the uses of model are different types. That is, in first one, waste management practices. As the model having chemical leaching or the erosion components can be determined the best practices over the long term. Next one, yield forecasting. Yield forecasting for the industries over large areas is important to producers and the processing agents as well as the marketing agents. Is the yield forecasting where to study the with the help of model, that is packaging practices, marketing strategies, and also the industrial processing agents and also the producers. The introduction of new crop in policy analysis tool. The agriculture research is linked with the prevailing cropping system in a particular region. Hence, the data concerned with the growth and development of the new crop in that region would be lacking. You know, today there is a lacuna between the introduction of development of new variety in the between the agriculture research and the prevailing the cropping system in the it will be concerned with there is lacuna of lacking with the new variety development. Then global climate change and the crop production. As they increase the concentration of the greenhouse gases, there will be the especially CO2 and the other gases contributing to global warming with associated with the changes with the behavior of the rainfall or uneven distribution of the rainfall, as well as long dry spells which will be observed due to the enhancing these greenhouse gases or contribution of greenhouse gases in the atmosphere. The limitations of the models as the agriculture system are the characterized by high levels of the interactions between the components that are not completely understood. This is the first limitation. Second one, that is models are therefore crude representation of the reality, and also the major however the knowledge is lacking. The modular or the models usually adopt the simplified equations to describe the extension of subsystems. This is third limitation. Fourth one, that is simplifications are adopted according to the model purpose and the developer's viewer, and therefore they constitute some degree of the subjectivity. This is a major lacuna of this model. And next one, the model that do not result from the strong interdisciplinary collaboration are often good in the areas of developer expertise but weak are in the other areas. And also the model quality is related to quality of the scientific data and the using the model development, calibration and validation. These are the major limitations of the model. And another one, that is most simulation models requires the meteorological data to be reliable and complete. Then meteorology sites may not be fully represent the weather at a chosen location. That's why there will be a limitation of this model. In some areas, data may be available for only one, that is a few data parameters or data for the solar radiation, which is important for the estimation of photosynthesis and the biomass accumulation, but it may be sometimes are not available. This is like from the meteorology sites, which will be do not get the proper data of these weather parameters. Then when a model is applied in new situation, the calibration and the validation steps are crucial for correct simulation. This is a major limitation. Then also need to be model verification arises because of all processes are not fully understood, and the best mechanistic model still contains some empiricism, making parameter adjustment vital in a new situation. Different limitations of the model which will be uh, facing under the during the development of the model. Thank you. This is today's topic about the model, different uses of the model, the model development and its limitations. Thank you.